Okay, now applications of quadratics. So the first type of application we're going to look at is finding domain, right? It's important that you be able to find domains because, again, it's just an important thing that you need to know how to do. All right, so domains with quadratics. We've done domains and other types, but this is domains with quadratics. Now I can solve quadratic formulas. I can solve for the zero. And see, these are all going to be division by zero cases because we're going to be looking for the zero because that's usually what we're asked to find. And so the first one is, what's the domain of f of x when you've got the rational expression, 1 divided by the quadratic x squared minus 7. Remember, we can't have division by 0, so we want all x such that x squared minus 7 can't be 0. And so basically we solve for those zeros and we throw them out. And so I can use my square root property in this case. I can solve for my x squared, so add the 7 to the other side. X squared equals positive 7, and then the square root property is x equals plus or minus the square root of 7. So square root of 7 and negative square root of 7 are the two that I can't have, right? You can't have those. And so interval notation and set notation. So the domain, using set notation, is every x such that x does not equal negative square root of 7 or positive square root of 7. The interval notation would be everything from negative infinity up to the negative root 7, or anything between the roots, or anything after the positive root. All values work except for those two roots. And we'll leave it exactly. It's exactly where there's a break in the function. All right, next example. Alright, so we have the line 2x plus 3 divided by the quadratic 2x squared minus 4x. So again, same thing. We want all x such that 2x squared minus 4x can't be 0. So we solve for the zeros. And so this is a special case, just like the first one was a special case, this one is as well. It's a special case where I can factor out the x, right? There's no constant term. And so I can pull an x out. And then it's going to leave me with a 2x minus 4. And so there are two answers. If I plug 0, if you check it, if you plug 0 in, everything's going to 0 out, and I'm going to get division by 0. And then the other expression also gives me a division by 0. And so 2 is the other one. So we cannot be either one of those. So we cannot be 2 and we cannot be 0. And so the domain, depending on which denotation you use, the set notation is every x such that x is not 0 or 2. Or interval notation, everything up to 0 works. Between 0 and 2 works, or from 2 to infinity works. Those are all of the areas that work. There's a break at 0 and there's a break at 2. All right, next example. My line, 1 minus x is divided by the quadratic x squared plus 5, and so again we want all x squared plus 5 equals to 0, can't equal 0, and so we solve for when they are and throw them out. All right, when I move the 5 over, I didn't write the step down, but when I move the 5 over, it becomes a negative 5. Well, if I try to take the square root of that, it's an imaginary number, and we don't want imaginary numbers. There's no real solution. And it should make sense. There's no real number that I can plug into a square term to make it negative. And so in this case, if you graph this, its domain is everything. I can plug every real number value into it. And so it's all reals or my interval negative infinity to positive infinity. Everything works. There's not a single problem when I plug stuff in that case. All right, the next example, which I believe is the last one, we've got the number 3 divided by the quadratic x squared minus x plus 2. So this is a full quadratic. So now we've got a bunch of ways to solve for the 0. You solve by graphing, by factoring, by using the quadratic formula. It's not in the special cases, so I can't use my special methods. So you have to use either the graphical method to find the 0, the quadratic formula to find the zeros, or the factoring to find the zeros. I'm going to solve it by factoring because this one I think is easy to factor. It's an easy factoring case, but you can solve it using one of the other methods. We want all x such that my x squared minus x minus 2 can't be 0, so we solve for the zeros. And I'm going to solve it using the zero product property. I'm going to factor. It's a simple case because of the x squared. X just splits up into x times x, and then what are factors of negative 2 that add up to negative 1? Well, it's prime. The only thing that 2 can split up into is 1 and itself, and one of them is a negative and one of them is a positive. We'll have a negative 2 and a positive 1, that works, right? If I take negative 2 times 1, I get my negative 2 out. And then if I check my middle terms, that's going to give me a negative 2x. That's going to give me a positive x. I'm going to be left with negative 1x. And so it checks. But yeah, like I said, you could use the quadratic case, graph it, find its zeros. As long as you find them, that's what matters. I think the easiest is the factor, and so this is the factoring method. And so we set each of those will give me out a 0. And so 2 is a 0, and negative 1 is a 0. And remember, we want to throw those out. We don't want those. And so I can't plug in 2, and I can't plug in negative 1, because that'll give me division by 0, and so my domain is everything but those. Every x such that x cannot be negative 1 or 2, or the interval notation, everything between negative infinity and negative 1, or between the negative 1 and the 2, or from 2 to infinity. And there's my domain. Alright, and so applications of quadratics finding the zeros in domain cases. All right, we're going to do a couple more applications, and that'll be the next video, and then we'll be finished with 3.2.